Okay, so the bad news is that we have that delayed release again today. The good news is that we have a 2-day lesson. There's not as much of a rush today, so I'm just going to take you as far as the other classes got, and then we'll stop there, and then the rest of it will be tomorrow. Make sure you bring these back tomorrow. Then what? Am I a gamer? No.
You look like a gamer.
I look like a lot of things. Gamer and oh, I know what. So yeah, 2-day lesson today, tomorrow, 1-day quiz on this. Steadily. All right. So today we continue with functions. You're gonna be thinking about who? Timon? No.
That's a bad word. It's a very bad word.
Look back on your desk says what? So tell me, you have your work cut out for you because Miranda's not here to carry you guys today. Oh, Visal's here. If you ever drown, Adam says he'll save you. All right, so let's go back to yesterday and tell me what are some of the things you remember about functions when you were introduced, Vinny Pooh. When we were introduced into functions yesterday, what are some of the things you remember?
Have an equal sign.
Okay, that's actually a good one. I haven't heard that. That's actually where I was trying to get to is, okay, he said that there's an equal sign. Even though we didn't really see a lot of equal signs yesterday, that's actually one of the things we want to focus on because, well, when I introduced you to functions, I said that a function can be most quickly described as an equation. It's really a type of equation, but what's the difference between the word when the word function is used versus the word equation? Oh, we learned quite a few things about functions, but I'm trying to guide you towards one certain aspect of it that is going to be important today. So he helped you out. He started off and said that there's an equal sign, yes. And we said it's an equation, but why don't we just call it an equation? Why do we call it a function? Come on, brainstorm. What else? What are some other things? Wow, very nice. Yes, very good. 2 variables. Most commonly, what are the variables?
X and Y.
X and Y, good. Okay. So today, yesterday we did a few things. It was an introductory lesson, but of the things that we did, we talked about domain and range, we talked about function tests, but of all the things that we did yesterday, probably the most important was evaluating functions, what we did towards the end, where you would plug in an X and get a Y, or plug in a Y and get an X. Going forward, that's what you have to know how to do most out of everything that we did yesterday. I guess domain and range is also important, but today we're going to graph. And there's a couple mistakes I have I printed those out and I realized some errors afterwards and I corrected them. So if you're going to be more specific, we're only going to graph linear functions today. We plotted points yesterday, but we didn't. We didn't graph lines. That's the whole point, is that today we're going to graph lines. Adam, you like lines? What, no, you like parabolas better? You look like a parabola guy to me. I mean, I remember the first day I saw you, I was like, wow, that kid must like parabolas. So our method for graphing is going to be predicated on the form that the function is written in. There's three main forms of linear functions. This one would probably be the most common. It's the one that all the children remember. Every class today, when I asked them what is slope-intercept form, they were able to recite it for me. What is slope-intercept form? There you go. Everybody's a collaborative effort. Good. Everybody chimed in. Y equals mx plus b. True story. It's like I actually considered pulling over the side of the road to take a picture because I was of how shocked I was. I actually saw this one time graffitied on the side of a building. Pretty prominently, somebody graffitied y equals mx plus b on the side of a building. Thought that was funny. I guess they must have been studying. They're giving out Gatorade in the bathroom? Oh. So what I want to do today is I want to be able to dissect these formulas so we can understand what type of information can be identified from there. So if we started off the lesson by Johnny telling us, hey, look, we're going to see an equal sign today. And then Georgiana helped out and said, hey, look, we're also going to see a y and an x. So if all the linear functions have those, what's left then to make each line look different? I drew a box around everything, around what's going to be there always. So what's going to change from function to function? B would be one of them. Good. And M, sure. So we need to know what those stand for. The M stands for slope, the B stands for y-intercept. I would assume most, if not all of us, know that. But I would also assume that most, well, I don't know, maybe most of us don't know exactly what those mean. Slope. Slope is not bad. Good.
Slope is your x, right?
Slope is not your x.
Are we going to learn how to find slope there?
You're a slope.
I know how to find slope.
Actually, yeah. Well, see, the thing with slope is that years and years and years ago, before they started dumping more and more standards into Algebra 1, there was enough time for an Algebra 1 teacher to give an entire lesson just on slope, where you would get 2 points and find the slope. That isn't necessarily the case anymore. So to answer your question, yes, we're going to find slope, but not in the traditional sense of here's a point, tell me the slope. But today's lesson does heavily involve slope. It's just kind of already are expected to know something about it. But I'm going to clarify. But just it isn't as intensive as I would like it to be. We'll get to slope later. Let's just focus on the B part and the y-intercept. Because a lot of kids don't know what this is either. Anybody know what y-intercept is? Go, Georgiana. Well, that's close enough. You didn't grammatically structure the sentence correct, but you put in all the keywords, so that's good. The most important thing you said is it's a point. And you said it's where the point. No, you would have said where the line. It is a point where the line crosses the y-axis. Okay, let's keep that in mind. Okay, this is a point. Y-intercept is a point. One of the very common mistakes, even though you didn't say this, but is for slope. A lot of people think that slope is also a point. Slope is not a point. Slope is not a point. Slope is not a point. Y-intercept? Yes, point. Slope is not a point. Slope is actually just a set of directions, like looking at a map. We'll cross that bridge when we get there. Let's keep on going. I'd say probably the second most popular form is called point-slope form. And this is what point-slope form looks like. Again, I'm going to highlight what you should expect to always see so that then we can figure out what makes this different. Gracias. If every function is going to have a y, oops, my box is wrong. Sorry, a y, an equal sign, and an x, then what's left to make each function look different when you're in point slope form? Well, yeah, well, that's you say that y1, or some people sometimes say y sub 1, but y1,
M.
m, and
X1.
x1, sure. So each of those have a meaning. In a little bit, we'll come back to these and we'll learn how to differentiate between the two, because we're going to have to identify each function, what form it's in. But m is still the slope. And look, I mean, we can do a little bit of comparing and contrasting. I just finished telling you that a y-intercept is a point, but it's just a very specific point. It's a point where the line crosses the y-axis. In point slope form, sorry. In point slope form, this x1 and y1 can be the coordinates of any point that's on the line. How many points are contained within a line? One. There's 1 point on a line. Who said that? Hey, Ahmed, what's up, man? Say it again. So, good. There are an infinite amount of points on a line. That's what the arrows mean, right? Now, yeah, what's the minimum amount of points you would need in order to draw a line? Well, really 2. Yeah, you can always draw 2 points connected. I asked for 3. I'm gonna show off today and do a bunch of points, but I would ask that you do at least 3. Because there's an infinite amount of points on a line, for any one given line, I could write that equation an infinite amount of different ways if I'm writing it in point slope. I can only write it one way if I'm doing it in slope intercept. This is more of an opinion, but I would say this is preferential up here for graphing. This down here is preferred for writing. Next week is when we're going to write functions. Miranda quiz on Monday. 2-day lesson on graphing today and tomorrow. Quiz. Then you have another 2-day lesson on writing, but then a quiz on Friday.
What is writing?
It's backwards. Today they're going to give you the function and you graph it. You know, there's some variation, but for the most part, next week will be the opposite. They give you the graph and then you write the function. It's going backwards. The problem becomes the answer and vice versa.
When we write the graph, are we going to have to solve this with thinking?
When they give you the graph, what?
When we have to graph it and they give us like a little equation or something, we're going to have to solve it, right?
Not necessarily, because her question was, today when we have to graph, are we going to have to solve? So I'm assuming that what she means by that, and we're going to talk about this in a little bit, is she's asking, because I know a lot of teachers teach it this way, I used to also, is that in order to graph, they force you to put it in this form. And in this form, y is solved for. I have kind of sold my soul, and to make it easier for the children, I'm going to actually just teach you how to graph in all the forms. Instead of having to turn them all into this one, I can just show you how to graph in all of them. Only if Adam says it's okay. Then the last form, and this is a little bit misleading because the name standard suggests that it's something that you use all the time, the same way kind of Naya turns around and talks all the time. But I could say that's what she does, like on a standard basis. But the word standard is a little bit misleading. Because of all the forms, this is the least useful. It has some uses when we get later on to systems, and we can try to get the most of it now, but when I look at this form, and I highlight, hey, look, every equation, every function is going to have a y, an x, and an equal sign. What's left to make each one look different? A, B, C, well, the thing is that A, B, and C by themselves don't mean anything. They're just numbers. They don't really mean much. But then Papa Romero comes in to save the day. And we can kind of extract some meaning out of these. Now, look, I'm not going to force you to turn this into slope-intercept, which is what we just talked about. But if I were, I could still make the process easier. Basically, look, I'm going to bypass slope. When they give you standard form, I'm going to show you a way where you don't have to know the slope. But if you did have to know the slope, you have a midterm coming up. When's the midterm? Next Monday. The 11th. The 11th. 3 Mondays from now. Simply, if on that midterm, for instance, they were to ask you what the slope of one of these is, here's a shortcut. As long as you know what A, B, and C are, do negative A over B. The negative means just change the sign. The easy way is just to change the sign of the first one. But you can only do one. So change the sign of the A and then divide it by B. But we're gonna bypass that today. Today we're not gonna use that. What? If they ask you for slope and you're given a function that's in standard form, then you can use it. The other forms, you don't have to do that because they're already giving you the slope. You can just look at it and tell what the slope is, as long as you know where to find it. Like here, like this is the first example we're gonna do. I'm not gonna do it yet, but see how it asks you to find slope? What form is this in? No, it's not a standard. This is slope-intercept. Well, I don't have to do anything because I can just look at it and it'll tell me what the slope is. But here's what we will use today. And this is another error I made, so you're gonna want to take out those pencil like the cavemen did. And this is what we're gonna use to graph. Normally I want 3 points, but for standard form, we're gonna get away with just 2 points. These are gonna be the 2 points. This part of your printout is fine. This part is not. So fix the y-intercept one. And that should say C over B. Don't come to me later on and say, oh, you didn't tell me. Tell me you're wrong.
Wait, which one?
The
B over A?
is wrong. Yeah, I don't know how
Like C over B.
I don't know how I messed that up.
Oh, you messed up the B and A.
You're looking at the A. I don't know. Look, the only thing that's wrong here, the only thing that's wrong is this. That should say C over B. All the other ones are fine. Not on your paper. Yeah. Seble. This is fun to say. I like this. It's fun the way she says it. Seble. Okay. So in order to be able to show you how to graph out of all 3 forms, we have to know how to identify the forms. The same way I just asked you, and Miranda knew, but then somebody else did not know. We're gonna have to know how to identify, right? So let's talk about what these have that are specific. How to differentiate between the forms.
No, you said my name.
Oh, because when we had this right, you said it was. Well, actually, was it Vinny that said it?
It was
both of them.
I think it was me.
Lies.
I said it last time.
You said that what?
Last time you changed it and you kept trying to do something to fight. I didn't do today. No, you talking about when I say standard. Wait,
I'm confused too. Just don't worry about it. It's not important.
Oh yes, I did.
You really want that phone? You keep on looking. I see you. I see you. Look. Need to connect to the outside world. Big things happening on the Twitter sphere. The way that we identify that a function is in standard form is that you're going to see the x and y on the same side of the equal sign. That technically x and y should also be a, b, and c should be integers, but we don't have to worry too much about that. Integers just mean that they're not fractions and decimals. But this is the big one, x and y on the same side. So when we see that, and we will see that today, you're going to say standard form. I would argue that more important than that, though, is knowing the difference between these two. We've already kind of alluded to it, but how would you know when a function is in slope-intercept form, the first one? Very good. There's an arrow being drawn to absolutely. The y is by itself. That's the big one. This is the only one that has y by itself. But you should also be able to juxtapose these and tell me, what does point slope have that the other ones don't? The parentheses. So I would kind of combine that and say, okay, for slope intercept, yeah, y is by itself, but also there's no parentheses. Because sometimes depending on what the values of m and v or m and x1 and y1 are, it is possible to make one look like the other, but the parentheses is exclusive to point slope, and the y being, well, I guess you could have y being by itself on this one. There is a way to make y look by itself, but if you have a combination of y by itself and no parentheses, then we're in slope intercept. And then the last boring part before we get to the fun examples is, well, what are we going to need? Well, today we're going to, I also wrote in what we're going to need for writing, but we'll cross that bridge next week. That's for next week. But for graphing, typically to graph, we need a slope and a point. The one exception to that is standard form, or I told you we're only going to need 2 points. We're going to just need 2 points for standard, but normally these are the things we need to know before we start to graph. And when that time comes, then we'll talk more about slope. Johnny's been dying to talk about slope. First example, no graphing, just identifying. For the second time today, yes, Kimon. Okay, well, what form is this in? How do we know slope intercept? Y is by itself and no parentheses. Good. So we should know that in front of the x is the slope we call slope m. I still don't know why. I've never bothered to look it up. I don't know why they use the letter m, but that's typically the letter that's used for slope. What's the slope here? -3. And then Kimon, what's the y-intercept? 2. If you were to be asked this on a test or a quiz, and well, again, it'll be multiple choice, but I'm perfectly fine with you writing it this way. But also be aware, what is, somebody not named Georgiana, tell me, what is a y-intercept? It's a point. So be prepared that this y-intercept might be written as an ordered pair. And if Georgiana said that a y-intercept is where we cross the y-axis, what do all the points that are on this y-axis have in common? That x is 0. So this might be x 0.
Okay, then. How you just get that M? How you just put it down like
Y equals mx plus b. Where do you find m in front of the x? What number is in front of the x here?
Oh, negative.
Where do you find b? Some people might tell you that it comes after the x, but it really doesn't have to technically. So the more important thing to understand is that b is either going to be added or subtracted. So, fact machine.
So why did you put B in the two? I know about why you put it in the point.
Well, because that's what it is, the point. Like, because this is a graphing lesson, so we're about to transition to graphing, and that number is a point, and it's a point that always falls on the y-axis. So what we're trying to show that is, as an ordered pair, every point that's on the y-axis has an x of 0. If we were actually looking at here, watch, perfect, let's look at the grid. Before we start graphing this, if I were to ask you what point is this, what would you say?
1.
No, it's not 1. Give it to me as an ordered pair. What point is that? You don't have to look that close. It's not
0, 1.
0, 1. Good. What point is this?
0, 2.
0, 2. What's this? 3. What's this? 0, 4. What's this? What do they all have in common? X is 0. Conversely, what do all the points on the x-axis have in common? If you were to name them, what do all the points on this axis have in common? The what? What's 0?
Y is
So y is 0. I'm letting you guys sit next together because I know it can be difficult with the language, and maybe you understand something that she doesn't, or vice versa. But if you guys get too distracted because you're so interested, then I'm gonna force you to sit next to Adam. Just kidding, Adam. All right, let's graph this. What form is this in? It is in slope-intercept form. So just like last time, I'm going to identify the slope and the y-intercept, and that's going to allow me to graph. But if you're not bored enough, this is going to give me an opportunity to talk to you more about slope. Let's talk about slope so that we can all know what slope is. What do we know already that slope is not? Slope is not?
A y-intercept. Point.
Slope is not a point. Okay, slope is not a point.
A negative.
Okay. Somebody else said that slope is an x, which I don't know where that came from, but we'll just pretend we didn't hear that. Slope is not a point. But okay, let's talk about what slope is. Because technically you are expected to kind of know something about slope when you come in. And even if you can't really explain it, when I ask kids, hey, what's slope? There's usually this little catchy phrase that they always remember. Rise over run. Very good. So let's use that, right? What does the over mean in rise over run?
Like over, like
No, you go up something and then left or right.
What does the over mean in rise over run?
turn, like turn.
Run.
Left or right?
Run.
Right or left?
Either one.
Straight up.
Jumping over
The symbol, you know.
Want to do charades?
Armpit.
monkey.
No. If I say 3 over 5,
A fraction.
hey, that's exactly what it means. The over. The over in rise over run means fraction. Rise, fraction bar, run. What that also implies indirectly is that slope, what slope is, it's a ratio. Slope is supposed to be a fraction. Now, when you write the function, you want to write it in the simplest form. So like here, what's my slope? What's my slope in this particular function? Oh, hold on. The slope is 3. So if all I want to do is write it, yeah, I'm supposed to write it in the simplest form, and that's just 3. But for the purposes of graphing, I need to identify a rise and a run. I'm going to want to write it as a fraction, and as Miranda said, in this case, it's going to be 3 over 1.
That was very interesting.
Really boring, yeah, but it's like interesting but boring.
I know the why.
Adam, you okay, man?
I know the me.
If you're falling out, I can see if we can borrow some chairs from Camp Creek next door.
I know the B.
Hmm?
I know the B.
Okay, what's the B?
4.
Oh, 4. Good. So in order to graph, we need a starting point. The y-intercept is going to act as that starting point. Everybody should know that the y-axis goes up and down. So we have one point. How many points are there on the line? Infinity. What's the minimum amount of points I need?
3.
I need at least 2, but I'm going to ask you for 3. I'm going to put more because of how cool I am. How do we come up with those points? Well, look, I am convinced that this has nothing to do with math. I think it's just pure laziness. You guys have a limit, and I say you guys generally, but I'm just saying the kids that struggle with it, like I will only learn so much, don't want to learn more, keep it simple. I see 2 numbers there, 3 over 1, so they go 3, 1, put a point, connect the dots. Hey, look, I'm done. I did something, I'm done. No. Because slope is not a point. What slope is a set of directions. Now that I have some bearing, now that I know where I'm starting, I can use slope to tell me where to go to find the rest of the points where I want, whether I want to find 1 more, 2 more, 5 more, 10 more. Slope is going to tell me where to go. Which number, based on, because we memorized rise over run, which number represents my rise? 3. So if I go up or down, because that's what rise means, up and down, I have to go up and down 3 at a time. But I'm going to do so from my starting point, from 0, 4. That's where I'm starting at. What number represents my run? 1. Run represents horizontal, it means left and right. If you're going to go left to right, it goes 1 at a time. But there's 4 different directions. Up, down, left, right. How do I know when to go up, when to go left? You're positive. But no, I'm just playing. She's not incorrect, but a better way of saying what Naya just said is what tells you where to go is the sign. There's 4 types of slopes. Positive, negative, 0, and undefined. Okay? These are their own little world here, so we'll worry about those later. We'll worry about the 0 slopes and the undefined when we get there. Let's focus on positive and negative. What type of slope because this particular problem has one of those 2 slopes. Which one? Positive, because 3 is a positive number. So we have a positive slope. But if we understand that slope is supposed to be a ratio, it's supposed to be a fraction, how can I divide 2 numbers and get a positive? But that would be the obvious one. Believe it or not, today that's like the last one I would always hear. You would think that's the obvious one. How do you divide 2 numbers and get a positive? Positive divided by positive. I agree. What else?
Negative divided by positive.
No, that's the one.
Negative divided by
No.
Negative divided by negative.
Negative divided by negative. Okay. The only thing that you do better than dunking is slope. So, what we can kind of summarize with that is say, hey, when you have a positive slope, both movements have to be in the same direction, either positive, positive, or negative, negative. If I ask you, hey, look, I went up, what sign do you associate with that? Positive. Positive. If I ask you, hey, if I'm going to the right, what do you associate with that? Negative. Positive. If you're going down, what do you associate with that? Negative. If you're going left, what do you associate with that? Negative. So if I just told you that on a positive slope, both movements have to be the same, you can go wherever you want as long as you abide by your rise and run, right? We just said, okay, like let's say the rise. The rise is 3, right? I have every right to go up 3 if I want on this one. But if on a positive slope, both movements have to be the same, not only should I go right, where else should I go? Down. No, not down. Not left. Right. What do you mean? On a positive slope, both have to be the same. You have to have a rise and you have to have a run. If I have already risen 3, where should I run? Donnie, stop tripping. And there's your 2 points. I prefer 3, but if you want to go up and to the right again, that's fine. Just make sure that when you go up, it has to be 3. When you go to the right, it has to be by 1. Suresh, you look so peaceful.
I think Suresh is out.
That's not. Is that right? That's not Suresh. I thought his name was Suresh.
It is. He was also peaceful.
That's Shruti. That's Shruti, and that's Matumbo.
But now what I hate, and you also have to wonder how much of this has to do with the fact that it's too hard or just lack of paying attention. It's like, when I ask somebody again later, hey, what do positive slopes go? They go up. No, they don't only go up. I have a right to go down if I want to also. And if I go down on this one, it has to be 3. But to make it stay positive, if I go down, now I have to also go left. I have to go left. If I go positive up, I have to go positive right, positive, positive. Or I also have the ability to go negative, negative.
Oh, yes. If it's negative, the rise is not. What? Huh?
Every line that has a positive or negative slope will go up, will go down, will go left, and will go right. You just have to know which ones to pair up. Do I pair up with right? Do I pair up with left? You're not going to pair up with down. That makes no sense. You have to have a rise and a run. Okay. The exceptions to that rule are when you have 0 and undefined, but we'll worry about them later. Okay? So you could also go down 3 left 1, down 3, left 1. And then the beautiful thing about this is if you do it properly, whether you have 2 points, 3 points, 5 points, 10 points, what should be true about all the points?
They line up.
That's why they call it a line. I have the benefit of technology to draw my line. What do you have?
A line.
A pencil? Well, no. Pencil's not going to help you draw.
Wait, so we only do 3?
I would like 3, yes. And 3, the benefit of 3 is even I make mistakes counting. Sometimes I don't use my fingers and I make mistakes counting. The more points you put, if you make a mistake, you're likely to catch it. If you just put 2 points, 2 points will always connect, even if they're the wrong points. But by adding extra points, you're more likely to maybe catch a mistake if you make one. Yeah, sorry. So back to my question. What do you guys need? You need a ruler. I hesitate to make a ruler a required material because I can't even get most of you to bring a calculator, and some of us don't even bring pencils. So if I ask for a ruler, that would be way out of line. But just try to have something that has a straight edge. Hang in there, Kimon. Would you like a group hug? Yeah. This is a positive slope. Look at the next one. I would have given you a packet, but you normally just leave them on the floor. So you just... What's the slope? What form is this in? This is also slope-intercept form. The reason why they call it the slope-intercept form is because I can just look at it and identify the slope and the y-intercept. What's the slope here?
-2.
Second period today is actually probably the next best class next to you guys. Today somebody goes, oh no, fraction. I guess that's a habit, but in this case, that's actually a good thing. Because for graphing, we want slope to be a fraction so that it's easier to identify. Yeah, you don't have to remember about the 1 on the bottom, like you see the fraction already. Y-intercept is 0, -5. Where am I going to start my graph? -5. Somewhat of a common mistake is that people confuse the axes. So Georgiana, y-intercept, up and down intercept. Now, once I get here, hopefully you can recognize that the 3 is going to be your rise and the 2 is going to be your run. But Adam, when I ask you where do negative slopes go, please don't say just down. Well, know that because slope is a ratio, it's division, it's a fraction. How can I divide 2 numbers and get a negative? No.
By negative and a positive.
1 positive and 1 negative. It doesn't matter if the positive is your rise and the negative is your run. So you need 1 of each. So if you were able to memorize it on a positive slope, either you both rise and run positive or rise and run negative. If you can memorize that for the positives, just remember that for negatives, it has to be 1 of each. I like to keep my graph small. If I'm starting below the origin, because the closer you hug the origin, the smaller your graph stays. So when I start below the origin, I like to go up. Not because I have to, I actually like to keep my graph small, so I like to go up. When I start above the origin, I like to go down. Not because you have to. But let's just say I stick to that, right? And I choose to go up. How far would I go up?
2, 3.
Not 2, I would go up 3 because that's my rise.
How is the negative?
Forget about negative, tells you direction. The only thing negative has to do is tell you up, left, down, right. So the 3 has to be the rise. Okay, I just chose to rise up. So, and if I know that on a negative slope, I need to have 1 of each movement, I've already used up my positive movement by going up. Where do I have to go next? Now I have to go to the left. Fax machine. So 3 up, 2 to the left, and I can keep on doing that as many times as I want. How much would I ask you to try to do that?
3.
3. I'm limited. Last period, it's the weirdest coincidence, man. Last period, I had somebody doing the exact same thing. I gave him one of the boxes to play with. Would you like to play with one of the boxes? If you can reach that high, sure. Yeah. There you go. Just don't break it, okay? No problem, man. Don't say I don't take care of you.
What a gamer, bro.
You know, like some, like these little kids nowadays, sometimes you get them the nicest toys, but they just want like something simple like a box to play with. Naya, so that you're not confused. Just because I decided to go up into the left doesn't mean I had to go up into the left. I also had the option of going down, which is fine, but I'd have to go down 3. And if I went down 3, where would I have to go next?
To the right.
To the right. And again, just like before, if you did it properly, regardless of how many points you have, what should be true about all the points?
It's straight.
Linear.
They should line up, yes. Okay. Let's speed things up a little bit now that we've kind of got things established and we have our grounding. Whoa, you just changed everything up. No, I didn't. What form is this in? How do you know it's a slope intercept? Y is by itself and no parentheses. But whoa. But I only see one number. Okay, cool. What's that one number?
Oh wait, no.
Is it a slope or the y-intercept?
Slope.
It is the slope, and it is to everyone, as I said. Very good. The y-intercept is 0, 0.
So you watch it 0 first. Then you rise to 1.
There you go, Adam, that's for you. I'm starting at 0, 0. Can somebody, it looks like Naya wants to try. Can somebody impress me and give me both distance and direction? Where can I go to find the rest of my points? What are the 2 possible paths I can take to find the rest of my points? Naya first. Up to? If I go? Right one, good. It's positive. Both movements have to be the same. So that's one. You could go up to right one without a beanie on. It's not a good look for you, man. I'm just trying to help you out. It's not. If you look good, then I can at least get it. But go, Georgiana. That's better, but it's not as good as you just taking it off completely. Huh? But give me distance also. Down how far? Down 2 and left 1. Good.
So we can do either way.
You can grab as many points as you want. Just grab your little heart. Sibling! Sky. Do your friends call you Vanilla Sky? Like the movie?
Yeah, too many games. Especially these days. Bro, I'm tired of you calling me a gamer. Like, I don't
Do you have a gamer chair?
Yeah, he does.
Yes, he got me headset too.
And got he, bro.
All right. We're still trying to graph, but now everything changed. Good, thank you. And how do you know this is the standard form? So, as a teacher, I have 2 options here. I could either teach you how to change this into another form, typically slope intercept, as Miranda suggested, which would involve having to solve for y, which we've done before. We've solved for variables before this year. Yeah, well, that's the thing. I'm going to show you, I don't know if it's an easier way, but what I feel is a quicker way. But if anybody really insists, I'd be more than happy to show you how to do it that way. Okay? What I'm going to show you to do, now the only burden here is this requires a little bit of memorization. But I'm going to just teach you to roll with what they're giving you. What are they giving you? Well, not much. They're just giving you A, B, and C. So, okay, what number's in the A position here?
6.
What number's in the B position?
2.
-2. What's it?
18. I remember it.
So instead of having to teach you to solve for y to use slope, we're going to just forget about slope. We're not even going to try for 3 points. Let's just go for 2 points, and let's make it 2 quickie points, the x-intercept and the y-intercept, and then just connect the dots. So now, instead of having to know how to solve for a variable and combine like terms, or actually not combine like terms and divide and maybe get fractions. Just memorize the formulas that fit on the first page. What is the formula for the x-intercept? Well, give me what it says on the first page.
C over A.
C over A, so 18 over 6. And what do we know about all the points that are on the x-axis?
No.
Y is 0.
Y is 0. Now, yeah, you're gonna want to. I don't think you were here for this, so you're gonna want to sit this one out. I made a mistake on the printout for the y-intercept. So somebody that was here when I told you how to
It's
get
C
it.
over B.
Good.
I was here.
I wasn't sure. And remember that y-intercepts have an x of 0. And the reason why I try to stress that is because you're half paying attention, maybe because Muhammad is so interesting. A common mistake that I see here is that you guys are like, yeah, x is 3 and y is -9. Cool. Yeah, so the point 3 -9 is there. No. These are two separate things. This tells you that on the x-axis, find 3. On the y-axis, find -9. And just connect the dots. Don't confuse the axis. 3, -9. Hey, Julia, do you like it better this way or do you like it better solving for y? I think most people would. You like solving for the y better? I don't mind. That's the way I used to teach it. I just found that this is quicker. I don't know what teacher is quicker.
Wait, what did you just say?
I-
I was thinking 9.
I just found the two intercepts and I connected the dots. Normally, I would advise you to graph at least 3 points, but for standard form, just keep it at 2. Keep it simple for the dots.
So that's all you do that?
Hmm?
That's all you do that?
For standard form.
I cannot see.
Those points be tripping. If like the only kind of drawback that you could encounter if you do it this way is sometimes these fractions won't divide evenly. But if we ever get to an example like that, then we'll try it the other way. But if you can get away with it this way, I would tell you to do it this way. Last one before our extended release.
Let's get
What form is this in?
Standard, bro.
Okay, so we can't identify too much just from looking at it, but let's use what they give us. Loganberries, what's A?
3,
Good, what's B?
2,
And what's C?
-6.
You were asking which is the last one. This is the last one for today. Georgiana. What is the x-intercept here? Well, I would have liked you to tell me C over A, and then I would ask you, hey, what's C and A? And you would say it's -6 over 3.
They give you 2.
-2, which is
I ain't heard that.
Baby.
and this one is C over B, which is -6 over 2.
That's 3, I think.
-3, which is 3. Hold on. I have a bonus. I want to graph this, but I still have a couple of bonus questions where you can show off everything you've learned. Don't confuse the axes, Adam. Put the -2 on the x, put the -3 on the y, connect the dots, and then just call it a day. But here comes a bonus question. We're done with what we were asked to do. We're done graphing. But now that we know what the graph looks like, if I were now to ask you what type of slope this function has, because we completely bypass slope. We haven't used slope here. What would you tell me and why?
It'll be a negative slope.
Why do you know that it's a negative slope, Timo?
Because the line is facing downward.
No, use your words.
It's going down.
It's
Left.
It's going from the upper thing
Left
to
to
the
bottom.
Say it again.
Left to bottom. Bottom to left.
I don't know how to explain it, but I know it's negative slope.
Top to bottom.
It's going up and to the left. That's you're the first person I heard say up and to the left, or down and to the right. Correct. Okay. On the previous one that we did, that was in standard form. Even though we did not find slope, what type of slope is the last one that we did?
Positive.
I still have time. What type of slope? What type of slope? What type of slope on the last one? You're looking at it. You're looking at the line. The line's in red.
Down to the right.
What? So what type of slope is it? It's not negative. It's positive. And why is it positive? Up and to the right and down to the left. One more. Let's say. No. Like I'm not doing another example. I just have another follow. It's the same example. So I need your attention. Or I can finish this in a minute if you give me just 1 minute.
Give them 1 minute, bro.
Let's say that just for fun, the question also asks you for, not just the type of slope, but give me the actual slope. Well, luckily I gave you a formula for that also. What was the formula to find slope in standard form?
It's negative 9.
No, it's
Why is it?
What is the formula? Somebody that still has the notes out.
Why is it?
What was the formula I gave you to find slope? Negative A over B. Negative A means get the A, change the sign. So like here would have been negative 6 over negative 2. Keep that the same. And wait, and you told me it was positive? There you go, it's positive. On the last one that we did, on the very last one, if they would have asked you not just for the fact that it's negative, but what is the actual slope here? What's the A is 3, so you would change the sign of the 3 to negative. Over the B, keep it the same. It's still negative 3.
Wait, so if we put the negative over negative 2, that'd be wrong?
Yeah, you gotta simplify. Alright, I'm done. You can just patiently wait for the bell to set you free. I'll staple it for you, don't worry about it.